The deepest hole on Earth does not look deep at all. It looks like a metal lid in the dirt, bolted shut, almost forgotten. But beneath that plate, a narrow shaft drops farther than Mount Everest rises into the sky. It falls through ancient stone, past buried water, past heat no drill was meant to survive, into a place humans reached once and then abandoned. This is Dark Atlas. On the Kola Peninsula, near Russia's border with Norway, the landscape feels like the edge of a map. Low hills, cold wind, snow-dusted rock, and industrial buildings scattered across tundra. And somewhere among them, sealed beneath steel, is the Kola Superdeep Borehole. Its deepest branch, known as SG3, reached 12,262 meters, more than 12 kilometers into the crust. For years, it was the deepest artificial point ever made in solid Earth. But the strange part is not how deep it went. The strange part is how little distance that really is. If Earth were an apple, the Kola borehole barely pierced the skin. And still, it nearly defeated everything we knew about drilling, heat, rock, and the hidden world beneath our feet. In the 20th century, the Cold War was fought not only in orbit, oceans, and borders. It was fought in symbols. First satellite, first human in space, first footsteps on the moon. But another frontier lay in the opposite direction, down. The United States had imagined drilling through the ocean floor toward the Mohorovičić discontinuity, the boundary between Earth's crust and mantle. That effort, Project Mohole, ended before reaching its goal. The Soviet Union looked at the same planet and asked a different question. What if the greatest discovery was not above us, but below us? In 1970, Soviet scientists began drilling on the Kola Peninsula. The site was chosen because its rocks belonged to an ancient piece of continental crust, billions of years old. To drill into them was to open a vertical archive of Earth's deep past. This was not a mine. It was not a search for oil. It was science on an industrial scale. The mission was simple to say and almost impossible to do. Drill as far as technology allowed, recover rock from the depths, and test whether models of Earth's crust were true. At the surface, the project looked like heavy industry. Towers, pipes, steel walkways, and workers guiding machinery through freezing air. But the target was invisible. The borehole was only about the width of a dinner plate at the surface, narrowing as it descended. It was not a tunnel large enough to enter. No person ever climbed down into it. No camera could simply be lowered to the bottom and look around. Instead, the drill bit cut into rock, bringing back cores, fragments, measurements, and clues. Each meter was data. The deeper the hole went, the more the project became a conversation with the planet. Rock temperature, pressure, magnetism, density, and chemistry. Every signal was measured, interpreted, and compared with what geologists expected. The first kilometers were difficult but manageable. Then came depths no drill crew had ever treated as routine. 6 kilometers, 8, 10. At these depths, Earth was no longer passive. It pushed back. A drill on the surface seems powerful. A drill 12 kilometers down is trapped in another world. The pipe string becomes enormously heavy. The borehole bends slightly. Rock closes in. Temperatures climb. Fluids behave differently. Metal expands. Electronics fail. Drill bits wear down in stone, compressed for unimaginable spans of time. To reach deeper, Soviet engineers could not simply make everything larger. They had to make everything smarter. They used specialized drilling systems, high-strength pipes, and methods designed to rotate cutting tools far below the surface. Instruments had to survive long enough to report conditions no human could experience directly. At the bottom, the drill bit fought ancient crystalline rock. At the top, the team fought time, money, and the limits of metallurgy. By 1979, Kola had passed the previous depth record. By 1989, it had reached 12,262 meters. That number became legendary, but the deeper victory was scientific because the hole revealed that some textbook diagrams of Earth were too simple. Before Kola, many models suggested deep continental crust would shift from granite-like rocks to denser basalt at certain depths. Seismic waves hinted at underground boundaries, and scientists tried to match those signals to layers of rock. But the borehole did not find the neat transition they expected. Instead, the deep crust was fractured, altered, and complicated. Rocks that should have behaved one way behaved another. Seismic boundaries were not always clean changes in rock type. They could be caused by pressure, cracks, fluids, or transformations within ancient metamorphic rock. Then came water. Far below where many expected dry crystalline basement, scientists found signs of mineralized water locked in fractures. This was not an underground river. It was fluid trapped within the deep crust, released and preserved through geological processes. The discovery forced a larger thought. Even the hard foundations of continents could hold hidden fluids. There were also microscopic fossils reported from deep rock layers, evidence connected to ancient life, and sediments transformed over immense time. Not life crawling at the bottom of the borehole, but traces carried in rocks far older than civilization. The hole was not a passage into a hollow earth. It was a library, and every kilometer made that library stranger. Then the story escaped science. In the late 20th century, a rumor spread that Soviet drillers had broken into a cavern deep underground, lowered a microphone, and recorded the screams of the damned. The tale became known as the Well to Hell. It had all the ingredients of a modern myth: a secret Soviet project, an unreachable depth, a recording no one could verify, and a hole that seemed to descend toward forbidden knowledge. But the story was not true. The Kola borehole was never wide enough to reveal a cavern full of fire. The famous scream recording was not a scientific recording from the site. It belonged to folklore, radio sensationalism, and the human habit of turning unknown places into moral landscapes. Still, the myth endured because the real project already felt impossible. A sealed hole in the Arctic, a drill descending beyond sunlight, temperatures rising, machines failing, scientists listening to Earth through cables and instruments. The truth did not need demons. The truth was more powerful. Humans had reached a depth where the planet itself became alien. The common reason drilling stopped is heat. And heat was central. Scientists expected high temperatures, but the rock was hotter than many predictions. Near the deepest levels, temperatures were around 180 degrees Celsius, far beyond comfortable engineering limits for long-term drilling. At that heat, equipment becomes unreliable. Drilling mud behaves differently. The borehole becomes harder to control. Rock that seems solid at the surface can become plastic, fractured, and unstable under deep pressure and temperature. Each additional meter costs more and teaches less if the tools cannot survive. But heat was not the only reason. The Soviet Union was approaching collapse. Funding became uncertain. Scientific priorities shifted. A project built by a superpower entered a world where that superpower no longer existed. Drilling at Kola stopped in the early 1990s. The facility later declined, and the machinery that once pushed toward the mantle became rust, silence, and memory. So why did humanity stop drilling into Earth? Because Earth is not empty space. It is not a void waiting politely for explorers. It is pressure, heat, chemistry, and time. At 12 kilometers, rock is not just something to cut through. It is an environment. And for the technology of that era, the environment won. Today, the Kola Superdeep Borehole is quiet. The most famous image is almost absurd. A circular metal cap, bolted into the ground, marked with the depth that made it famous. Around it, the remains of buildings and roads sit in a cold northern landscape. There is no open pit, no dramatic crater, no stairway into darkness, just a sealed point on Earth's surface, covering one of the most extraordinary vertical journeys ever attempted. Other boreholes have since surpassed Kola in measured length, especially in oil and gas drilling, where wells curve horizontally for great distances. But Kola remains iconic because of what it represented: a direct scientific attempt to penetrate the continental crust. It proved that deep Earth was more complex than expected. It showed that fluids could exist in deep crystalline rocks. It challenged simple ideas about crustal layering. It gave scientists real samples from a place almost no one will ever touch. The hole is closed, but the questions it opened are not. There is something humbling about the Kola Superdeep Borehole. Human beings have crossed oceans, mapped continents, walked on the moon, sent spacecraft beyond the planets, and photographed galaxies billions of light years away. Yet beneath our own feet, after more than 12 kilometers of drilling, we had crossed only a fraction of Earth's outer shell. The planet we live on remains partly unknown, not because it is far away, but because it is close in the hardest possible way. Kola reminds us that exploration is not always a flag on a summit or a footprint in dust. Sometimes it is a core of ancient rock lifted into daylight, a temperature reading from darkness.